Physics 2211, Lab 1, Constant Velocity. In this lab report, I will first introduce the experiment and then explain its two components, the tracker analysis of a physical object and the computational model. I will then follow with the results and the discussion. The purpose of this lab is to investigate the motion of an object moving at constant speed without changing direction. I will do so by comparing the tracker analysis of the motion of a physical object and the predicted motion from a computational model built in Glowscript according to the fundamental physics principles. These are Newton's first and second law. According to Newton's first law, if F net is equal to 0, a moving object will stay in motion and an object at rest will remain at rest. So an object moving at constant velocity, if its net force is 0, will continue moving at the same constant velocity. Newton's second law, also known as the momentum principle, states that F net is equal to the derivative of momentum with respect to time. From this equation, the following velocity and position update formulas were derived. They will be used in this experiment to predict the motion of an object moving at constant velocity. I will be using a cylindrical container to roll across a table to observe the motion of a physical object. Tracker will be used to extract time, position, and velocity data. The initial conditions found from the tracker analysis will then create the foundation of the computational model, which will make use of the formulas outlined above. The main result of this experiment is that the physical object does not have constant velocity due to the non-negligible effect of forces in the surroundings, in contrast to the key assumption of this experiment that the net force on the object is 0. This will be further explained throughout this lab report. The motion of the medicine bottle was observed using tracker, and the initial position was defined as 0, 0, 0 meters, and the initial velocity was calculated from the first two pairs of time and position data using the equation velocity is equal to change in position over change in time. The velocity found was negative 0.12400 meters per second. The system is the medicine bottle and the surroundings are the table, air, and everything else around it. I define the axes as positive x to the right and positive y upwards. In this case, because the medicine bottle moves from right to left, it is moving in the negative x direction, which is why the velocity was calculated as negative 0.12400 meters per second. The key assumptions of this experiment are that the object does not experience friction or air resistance in order to assume its net force is 0. The computational model was built in Python code in Glowscript to predict the motion of the object based on the initial conditions from the tracker analysis of the physical medicine bottle. The mass has been left as the default value of 1 as it does not affect the calculations. The initial ball position has been set as the vector 0, 0, 0, and the initial velocity as the vector negative 0.12400. The starting time is 0 seconds and delta t is 1/60th of a second because the tracker video was shot in 60 frames per second. The while loop runs until t is less than 1.051 seconds, which was the last frame in the tracker analysis. The velocity and position update formulas have been modified accordingly into Python code to allow for the iterative prediction of the motion of the medicine bottle. The resulting graph shows both the observed and predicted motion, and it can be seen that they are very similar in the beginning but start to deviate as time increases. The orange line representing the tracker analysis becomes less steep, indicating a decreased velocity due to the non-negligible effect of friction and air resistance that leads to a non-zero net force. The physical object thus does not move at constant velocity, and the computational model is unable to predict that due to the lack of correction for these forces. For the what if and what does it mean questions, if you flip the axes so that positive x and negative x were flipped, the downward sloping graph would become upward sloping. This would be the only difference. For the second question, no, we cannot really say how many pushes and pulls are added together to give 0 net force because we do not know exactly how many forces are acting on the object nor what they all might be. They're too complicated to say. Some of them likely include the gravitational force and the air resistance and friction that act in the opposite direction of the object's motion. Potential sources of error in this experiment may be from human error due to the inability to select the middle of the object consistently in tracker. There may also be an accumulation of rounding error in the Glowscript model that makes it seem more inaccurate than it may be. Overall, in conclusion, objects in the real world do not have a 0 net force because forces from the surroundings constantly act on them. This was evident from the deviation seen on the graph between the observed and predicted motion. Thank you.